Hi, my name is Alice, and this is an introduction to my syntax course. So first off, some background. Alice is not my real name. This is just a general name from Bob and Alice. I am moving in soon to live with Bob, and therefore I will need to make a roommate agreement. In the roommate agreement, we have a guest agreement as well. And all guests must read the guest agreement, which is all written in my syntax. And therefore I require all of the guests to watch this video as well as all of my other syntax videos in order to understand the agreement and know how to use the syntax. So, first things first. I'm a mathematician, Bob is a physicist, and therefore we use math syntax mostly. Also, some of our syntax is from computer sciences. I personally prefer C++, so you will have a lot of loops. Now the first thing that we'll learn is how to define functions here. So how do we define a function? It's pretty simple. For example, let's say that I, Alice, want all of my guests to stay clean. But clean is not very well defined. What does clean even mean? Clean means, for example, that I cannot see specks of dust on the floor, or that you can have a minimal amount of specks of dust. So I will say clean at time t. I will define, for example, what's cleanliness at time t. So let's do the following. I will write my functions in red as part of the divine order, which all the guests will also have a test on. What are the colors of the divine order? So cleanliness of guest x at time t. Let's make first off, let's say this. For all x in people is a set, right? We can define a set of all people in the world. For all x in people, we'll define what is the cleanliness of x at time t in time. X can be sometimes sloppy and sometimes clean, and that's why we need to say t in time. And for all t in time, how will we define this? We'll say the following. We'll say that cleanliness of x at time t is going to be the following. We don't need to say exactly how many specks of dust, because that is going to be too complicated, right? So we'll do something much simpler than this. We'll say what is acceptable and what is unacceptable, so we'll do a different scale. We'll say the following. How should our scale go? We'll take a trinary scale, which means 0, 1, and 2. We'll keep it discrete as to keep things simple, because there are so many functions in the world that we cannot properly define everything in the most precise way, though we wish we could. So we'll say 0, we'll say that it means this is totally unacceptable. Whereas 1 is acceptable but not exemplary, and 2 is exemplary cleanliness, very clean to a point that X deserves an award. We'll talk about awards and punishments in our next video, which will be if loops. So what will happen? We'll write this now in orange. So 0, if for example, what is 0? If the amount of dust, if I can carry out how many times will I have to sweep the floor? Let's think of it like this. Alice sweeps the floor after all guests. So, how many times will Alice have to sweep the floor? Over, let's say the following, over 10 floor sweeps. Now here, what will happen for 1? For 1, we'll make this a little bit bigger so that I can write, and so that you guys can see something. Now 1. If Alice has to do between, let's say, between 2 to 10 floor sweeps. So let's do it like this. Floor sweeps. We'll write that FS. Damn it. Now I'll have to erase this properly. Two to 10 floor sweeps. Fair? So Alice has to sweep the floor, and now we'll say that you were very, very clean, exemplary clean at time t if Alice has to do less than 1 floor sweep. Fair? So this is how we define the certain function. This was only one example of a function. Now let's think of other things that Alice and Bob find to be important. First off, Alice loves to have a clean house. That is me. I love having a clean house. But what other things do I like, and what other things do Bob like? So, first things first, we're both vegan. So, but that we'll talk about next lecture, because that's an if loop. Because there we only have 2 relationships, which is either you stay vegan in the house or you're not vegan in the house. But now let's try something that has a little bit more of a scale so that we can write a slightly more interesting function, such as decibels. We're both students, and therefore we like to keep quiet. So let's try a different function. Let's give a situation. Pretend that Bob is studying, and Alice brings over a friend. Because Alice just so happened to finish her homework or something early that week, which is a pretty likely situation. So Alice brings over a friend. Now, the friend and Alice want to talk, but Bob has to study. Alice has to respect Bob's need to study, and also the friend has to respect Alice's need to respect Bob. So, now we'll do the following. We'll define when is a friend talking too loudly. How can we define this? We won't say when the friend is screaming, because how do you define screaming? Oh yeah, we define screaming through a decibel scale. So, we'll do the following. At all times, we once again have to do for all x in people, because x is a person, Alice's friend in this case, for all time in t in time, sorry, I keep on confusing this, hate spoken language. For all x in people, for all t in time, how will we define how loud t is, whether or not it's acceptable or not? So let's say this, volume will be our function. Volume of x at time t shall be, once again, we'll do a trinary scale. Alice personally prefers binary, but, well, we can do it like this so that we can have a reward system and a punishment system. But let's see, do we really need a reward? No, you're kind of required to be quiet, so we'll only have a punishment and no punishment system. Fair? Awesome. So we'll do the following. It will be 0, in which you'll get punished, and 1, in which you won't get punished. So volume of x at time t will be 0 or 1, according to the following. 0 if x talked in under, if x spoke under 90 decibels. Spoke, 90 is a bit strict, right? Well, anyways, we'll see in the decibel scale. 90 is quite strict. So let's say that x is allowed to talk under 120, let's say. Spoke under 120 decibels. This will be x spoke over. Oops, let's switch this around, over 120 decibels, because in this case x gets punished. X spoke under 120 decibels here. Now this was a very simple function, only we have several problems here with this function. We didn't look into other factors. 120 decibels, why did we decide on 120 decibels? We decided on 120 decibels more as an average. But what if we wanted to make a guarantee so that we could say that X always must speak under a certain amount of decibels? We cannot do that because ideally that would be 0 for both Bob and for Alice. But let's say that, but then after that we could improve this function by doing the following. We'll do volume of X at time t and we'll write it like this. Only, now we'll say we have more cases. This will be case 1. Case 1 here will be the case in which, let's say, Bob has homework. Bob has homework. And then after that we'll have case 2, which will be a very similar case to case 1, right over here, which is when Bob doesn't have homework. We had to write 2 cases so that we can define the constants, in this case the number of decibels, in a different way for all of our cases. So this is the basic syntax of how to write functions. I hope that you all learned something. In the end test, you'll have to write a function of your own describing something, and you can choose your own constants, but try to be considerate of Alice, because in the end, Alice, will be checking the test. Thank you for watching, and I hope to see you next time with our if loops tutorial. Bye bye.